So I'm going to be explaining the materials and methods and results for the egg yolk. When going about our methods for the egg yolk for extraction and separation, we based it off of Kowalczuk's and Dumas' study. We used it because it had very similar intentions and results that we were looking for, which was basically the composition of fatty acids within the egg yolk. So basically, when going about separation and extraction, we used a series of ethanol and hexane separations, and we put these into a separatory funnel so we could see phase separations and ultimately purify it down to its purest form. And after our series of separations and extractions, we used that supernatant that was removed from the separatory funnel into an ice bath to create a precipitate that would go through ultimately 3 different further methods that would go more in depth of what fatty acids were in our egg yolk. So first we have TLC, which is the first figure with the little blue dots, and this method was basically used for the separation of all the components within the egg yolk, but we got like a lot of our components, but we wanted to go a little bit further, so we used gas chromatography, which is the second figure with the 8 different peaks. And this method was used to further separate, quantify, and help identify the different fatty acids in the mixture, but we wanted to go even further, so we took these peaks and we used mass spectrometry. So we used this method. It's a gas chromatography detector by scanning the masses of the peaks during separation, leading to the ultimate identification of the fatty acids. So when we're looking for those fatty acids, we took the largest peak. See, the top red peak is the saturated fatty acid, and the bottom one is the unsaturated fatty acid. So going first with the saturated fatty acid, we would take the highest peak mass, and that would be the mass of the entire fatty acid. Then we would subtract 74 from that to account for the methyl ester. And then we would divide by 14 because we need to account how many CH2s were in the fatty acid. That is the key in determining what the fatty acid was. But if we were to divide by 14 like we would in an unsaturated fatty acid, we would see that we don't get a full number, so we would have to subtract 26 from this total to account for the CC double bond that would be in this fatty acid, just like the peak at the bottom. So after subtracting 26, we would divide by 14 again to see how many CH2s there were, and so ultimately that is how we figured out the different fatty acids. And here in this last table, it says the peak number, it's like fatty acid number, and then the fatty acid name. So